In 2025, the concept of vibe coding went viral. It promised a future where developers could stop worrying about the precise mechanics of code and start building software by simply expressing their natural language intent. For decades, the primary interface between human and machine has been grammar, curly braces, semicolons, and type annotations. Vibe coding moves that interface toward directing high-level outcomes instead of managing syntax. This progression has been building for years. We moved from simple autocomplete predictions to chat-based code generation, and finally to autonomous agents that can clone repositories, plan architecture, and execute multi-file edits without a single human keystroke. By removing the need to manually translate logic into specific grammar, the speed of software creation is no longer limited by how fast a human can type. This loop shows the core mechanics of an AI agent. Unlike a chatbot, an agent runs its own cycle. It perceives a goal, plans its steps, takes action through tools, and observes the results to decide what to do next. But that autonomy carries massive risks in a production environment. A weekend prototype can survive on casual vibes, but a mission-critical payment processing system cannot afford an AI that guesses its way through the implementation. The trap of pure vibe coding is the belief that writing 1,000 lines of code before lunch is the same thing as shipping reliable software. Speed without a verification structure is just technical debt at scale. To trust these autonomous outputs, we need a method to bridge the gap between it seems to work and it is correct. This spectrum organizes how developers use AI. Vibe coding relies on casual prompts and manual spot checking, treating code as disposable. Agentic engineering shifts to formal specifications and automated evaluations, operating within a system of human-designed tests and CI/CD gates. The defining line isn't whether you use AI, but how you verify the output. If the system relies on a developer saying it looks right, it's vibe coding, regardless of how sophisticated the model is. When an agent fails, the common reaction is to blame the model and wait for the next smarter version. But a smarter model doesn't automatically make the agent safer or more reliable. The reality is that an agent is a combination of two parts, a reasoning model and a harness. The model is the engine, but the harness is the machinery that makes the engine useful. Looking at this anatomy, the model is just one input. The harness represents 90% of the architecture. It contains the tools, the orchestration logic, the sandboxes, and the guardrails that prevent the model from drifting. Most agent failures are actually configuration failures. If an agent goes rogue, the solution is usually found in the harness, by tightening the rules or adding the missing guardrail. In the traditional software development lifecycle, the implementation phase was the ultimate bottleneck. Translating designs into code was a manual process taking weeks. Agentic AI changes the math. As this timeline shows, implementation is compressed into minutes. This moves the human bottleneck to the edges of the process. The work is now concentrated on writing precise architectural specifications at the start and rigorously evaluating the agent's reasoning trajectory on the back end. The craft of software engineering hasn't disappeared. It has shifted. Code generation is now a commodity, which makes verification and judgment the most important skills in the factory. This shift creates the role of the orchestrator. Instead of typing out lines of syntax, the developer designs the assembly lines of agents and the automated tests that verify their work. But an agent's harness and guardrails are only useful if that agent can securely reach out and manipulate the external world. To master this new workflow, we have to look at how agents actually interact with databases and APIs. In our next episode, we'll dive into the hands of the agent, tools, and interoperability.